Thank you for joining me for this trigonometry exercise. I am Mr. Ish. I hope everyone's doing good. We have this representation here provided to me by a viewer. How can you use this representation here to verify this cosine difference formula? You know you could use x's and y's. Here we're using alpha and beta in terms of our angles. The cosine difference formula, cosine alpha minus beta or x minus y. You know what it is. You'll have cosine alpha, cosine beta plus sine alpha and sine beta. How can you verify or even say the word prove it? You have this representation over here. You're focusing here on this top triangle. You see this dimension C over here? That's what we're focusing in on this little segment here, which has a length C. You have a beta, the smaller angle. You have alpha, the larger angle. Consider theta to be equal to alpha minus beta. You know what that would mean. You're looking here at this angle and it would be theta. Everything will stem from there. Therefore, you must start aiming yourself towards determining this length. Look at this top triangle and draw it out on an x and y plane. You have this side here, it's equal to 1. That side here is equal to 1. Therefore, this here is not a right triangle because you have one leg equal to 1, the other leg equals to 1. If it were a right triangle, this hypotenuse must be larger than that. But since they're equal, you have an isosceles acute triangle. You have one leg here which we can say 1, 0 because it has a side 1. You have another leg which is also 1, and then you connect the 2 points. Therefore, you are looking at this angle right over here, which is that. The angle here is theta, which is the difference between an alpha and a beta. Draw a right triangle and you have an x dimension and a y dimension and determine this point. We'll call this point P. You have cosine theta is equal to x over 1, which is just x. You have sine theta is equal to y over 1, which is just y. Y is equal to sine theta, x is equal to cosine theta. So you have a cosine theta and you have a sine theta. Determine this, and it's also equal to c. Determine this length of segment using your distance formula, and you can easily do it. You'll do the square root y2 minus y1 whole square, which is a minus sine theta whole square, plus x2 minus x1 whole square, 1 minus cosine theta whole square, and this right here is equal to your length of segment C. Now we'll do everything by focusing on this representation. You have this point cosine beta, sine beta. You have that point cosine alpha, sine alpha. Because these are equal to 1 and 1, you can easily determine those points by respective right triangles. Here's your one right triangle, here's your other right triangle, and you can easily determine those points. It's not hard at all. But that's the item depiction which is already provided for you in the question given to me by the viewer, and we're going with this depiction. Let's look at this C and we will determine it using also the distance formula. Here in this representation, C is equal to y2 minus y1 whole square, sine beta minus sine alpha whole square, plus x2 minus x1 whole square, cosine beta minus cosine alpha whole square. This equals C, this equals C, they both equal to each other. And then you solve and you simplify using both of these expressions equaling to one another. We'll finish everything up over here. We know in all instances theta is equal to the difference between alpha and beta, so we have to remember that. We'll open up this expression right over here. We'll open up this expression, but we can, before doing that, square everything and eliminate the radicals. This square and that square, the roots will go away. Now look right over here and let's open it up. We have sine square theta plus, we'll open this part right here, 1 plus cosine square theta minus 2 cosine theta is equal to all of this. We have to open it up. Let's open this part, we'll open this part. Here we'll have a sine square beta plus sine square alpha minus 2 sine alpha sine beta, and open this right here. We'll have cosine square beta plus cosine square alpha minus 2 cosine beta cosine alpha. Now we bring in the wonderful trigonometric identity that allows us to eliminate a lot of things. Sine square theta and cosine square theta are equal to 1. 1 plus 1, which you already have from before, minus 2 cosine theta is equal to sine square beta, and cosine square beta is equal to 1, because that's your basic trigonometric identity. Sine square alpha and cosine square alpha is equal to 1, that's another one. Minus 2 sine alpha sine beta minus 2 cosine beta cosine alpha. This 1 plus 1 and this 1 plus 1 will cancel out. But then look, everything is a minus 2, minus 2, minus 2. You can eliminate or divide everything by a minus 2 and eliminate all of these minus 2's. And look what you end up getting. You end up seeing here cosine theta is equal to sine alpha sine beta plus cosine beta cosine alpha. But what was theta equal to? Theta was equal to alpha minus beta. So then you say cosine alpha minus beta, which is like your difference formula, equal to, then you look right here at this expression and write it in a good way. You can write the cosine first. You can do cosine alpha, cosine beta. Order does not matter when you're multiplying. Plus sine alpha, sine beta, and here is your cosine difference formula, and we're done. Everything coming here from this representation and the interplay of this length dimension and this length dimension by means of two different routes, bringing them together because those two different routes were equal to each other. Thank you. Have a good day.